So we're going to look at solving radical equations in two stages. In this first stage, it's just going to be with a single radical that we're starting with, and then in the next video we'll cover what if there are two radicals. So our general steps that we want to follow is that first thing we want to do is isolate the radical, meaning you want to get to a stage where you just have whatever root you're taking of whatever expression equal to, and then typically just a number on the other side. So you want to solve things so that you just have the radical symbol on one side and a constant on the other. Then what we can do is raise both sides of the equation to an exponent that will eliminate the radical. So what that's going to look like is when we get to the stage where we're taking this nth root of whatever, and that equals some number, what we can do is raise both sides of the equation to an exponent, and the exponent you're going to choose is going to match the radical. So whatever level root you're taking, that's the level of exponent that you want to use. And what that will do is that whatever's underneath the radical then, whatever's underneath the radical, the root and the exponent cancel each other out. So then you can get outside of the radical with that expression that was underneath, and then equals whatever that number is raised to that nth power, and then you can go through methods of solving the equation. Now, in terms of solving the equation, sometimes it'll be a linear equation, sometimes it'll be a quadratic equation, so we just want to pay attention to what we're dealing with and making sure we use the correct methods to solve. So, let's try, one more very important step is that we have to check our solutions here. We absolutely have to. With linear and quadratic equations, it is just kind of kindly suggested to do it because, checking your answers is great for everything, because if you check it and it works, then you know you have the correct answer. Here, there's a chance that we get solutions that aren't actually solutions. It's very rude, but it happens with these. Basically, when we get to graphing, we'll see how our domain is limited, whereas with linear functions and quadratic functions, we could plug in anything and it was fine. Here, there's going to be these little things that happen while we're solving, and will give us a solution that's actually outside of the domain, so it can't work for our radical function. So, checking solutions is something we'll have to do. Okay, so with this first example here, what I can see is my radical symbol, and what I can notice is that it's all alone on one side of the equation, so I don't need to move anything around. There's nothing happening outside of it, so we can skip that first step. Then what we're going to do is raise both sides to an exponent, and what I'll notice is that we're taking the square root, so I'm going to square both sides. So when I do this, what's going to happen is this expression that's underneath the radical is going to be able to break free, because that radical and that exponent cancel each other out. So what I'll have is just x plus 1 in that next step, and the radical's just gone because of that exponent. And then equals 3 squared, which is 9, and then I'll go ahead and subtract 1 from both sides, so I get x equals 8. And then we just need to check. So with that, I'm going to plug in my value for x. So where we have x plus 1, I'm going to check 8 plus 1 and make sure, is that equal to 3 that we have on the other side of the equation? Well, that's a square root of 9, which I know is equal to positive 3. So we have our answer. X equals 8. Alright, our next example here, so the square root of 3x minus 5 plus 7 equals 3. So first thing we need to do is isolate our radical symbol, and with that I need to subtract 7 from both sides. So square root 3x minus 5 equals 3 minus 7, which is negative 4. Then I'm going to raise both sides to an exponent of 2 since we're dealing with a square root. So with that, the expression that's underneath the radical will be outside of the radical now. And then negative 4 squared is a positive 16. We're going to add 5 to both sides. Divide by 3, which will give us x equals 7. Now I need to check that it works. So what we're going to do is take the square root of 3 times 7 minus 5 plus 7 on the outside of that radical, and that should equal 3. So square root of 21 minus 5, which 21 minus 5 is 16, which is 4. And as I can see, this is not going to balance out because we end up with 11 on one side and 3 on the other, and that does not equal each other, which tells me that x equals 7 is not a solution. And since there aren't any other options, what that tells me is that for this equation, there is no solution. So let me show you what's happening graphically with these, because in terms of solving equations, it does come down to looking at two graphs and where they're intersecting with each other. So like for our first example that we did, that square root of x plus 1 equals 3, what I could do is take the square root of x plus 1, and I could graph the horizontal line y equals 3. And what I'm interested in is where are they equal to each other. And there we can see our x equals 8. So that's where we're getting our solution, and it's that x value from the intersection of those two graphs. This is great for checking your answers too. If you check algebraically, and say you check algebraically and it doesn't work out and you go to fix your work and you just can't get it, this is a way to see the answer and maybe reverse engineer it, kind of work backwards to get that solution. So our second example, that 3x minus 5, and then with a plus 7 on the outside, and then I'm comparing that to y equals 3, and what we can see here is those are not going to intersect with each other. Y equals 3 is way down here, and my radical function is way up here, and it's not going to move any further than that. This is what I was saying about our domain being limited, so we just need to be careful of any extra solutions, which what we got was, yeah, we can't even visualize it, so we're not going to. So with that, we can see they never intersect, and that would confirm that there really is no solution between the two. Alright, our next example here. So what I want to do is work on isolating this square root of x term. Oh, sorry, before we go on to that, there's one more thing I wanted to point out in terms of when you're solving and when you could get a clue that there's going to be no solution. My clue came in at this step right here. Having a square root equal a negative number just can't happen. With even roots, you're not going to be able to take the even root of a number and get a negative number out. It's part of our restriction on these even roots that we're taking. So it's when I'm at this stage of solving that I would make a mental note of, well, I'm probably going to get extraneous solutions here. I want to keep solving just in case a real solution does come out. You just might have an extraneous solution to go along with it. But in terms of getting a hint of when that'll come up, when you have this situation of square root equaling a negative number, that can typically lead to this no solution or extraneous solution scenario. Okay, now we can move on to this one. So I want to isolate the square root of x term. So what I'm going to do is add 5 to both sides. So I have 3 times the square root of x equals 7. Divide both sides by 3. So we have square root of x equals 7/3. I'm going to square both sides of the equation so that that radical and exponent cancel each other out, so we'll just have x equals 7 squared is 49, 3 squared is 9, and I will leave it just like that, since there's nothing to simplify down there. But what I am going to do is check my answer. So 3 times the square root of x, which we're saying is 49 over 9, and then minus 5, and that should equal 2. So simplifying the radical, square root of 49 over 9 is 7/3, which those 3's would cancel, so this is 7 minus 5, and that does in fact equal 2. So we're all good to go, and we have our solution of 49 over 9. Alright, last example here. Our radical's all isolated, so we don't need to move anything around. I can just go ahead and square both sides of the equation. So that'll give us a 3x minus 5 with no radical equals 2 squared, which is 4. We're going to add 5 to both sides of the equation, which will give us a 3x equals 9. Divide both sides by 3. That'll give us x equals 3. And then before we can confirm that solution, we need to check it. Then we go square root of 3 times 3 minus 5, and I want to know, is that going to be equal to 2? Well, square root of 9 minus 5, which is the square root of 4, which is equal to positive 2. So we have our solution, x equals 3. Alright, so this is a case where we just have a single radical showing up in our equation. In the next video, we'll go through what to do with 2 radicals.